Hello future doctors. I'm Mr. Ujjal Kanti Roy, medical mentor, biology faculty and founder and director of the Engineers Gurukul. I have come up with another video on the protein part, which is the most important for NEET examination from Biomolecules chapter of class 11. And in this video, I'm going to talk about the different classification of protein on the basis of its constitution, and then I'm going to talk about the classification of protein on the basis of its structure. So first, on the basis of constitution, we can classify protein into three. One is simple, the second one is conjugate, and third one is derived protein. When we talk about simple protein, that is, we are talking about only a protein which is made up of only amino acid. So it's not having any of prosthetic group. So if it is made up of only amino acids, then the example is going to be myosin, keratin. These are the examples of it, because they are made up of only amino acids. But when we talk about conjugate amino acids, that is, they are made up of amino acid, along with that they have got prosthetic group. And this prosthetic group, on the basis of different types of prosthetic group, we have classified conjugate into 7 different types. And mind you, I made a star mark on this because this is very, very important for your NEET examinations. Phosphoprotein is number 1, where when we talk about phospho, means it's a phosphate, and protein means it's made up of amino acids. So amino acids, so what is the prosthetic group out here? It's the phosphate. So the example is casein is the milk protein, we already know that. Casein of milk is the best example of phosphoprotein. The second one is nucleoprotein. So the prosthetic group over here is nucleic acid. So the example is DNA and RNA. When we talk about chromoprotein, chrom is color. So the prosthetic group over here is chromo, color. Phytochrome, cytochrome are the examples of it. Glycoprotein, glyco is what? It's carbohydrate. We know that. So the prosthetic group over here is the carbohydrate. Example is mucopolysaccharide or mucin. Luteinizing hormone, LH, and follicle stimulating hormone, FSH. So these are the examples of glycoprotein. Metalloprotein over here, in the examples is hexokinase, where the metal is magnesium. Plastocyanin, where the metalloprotein is, the metal is what? Copper. And carbonic anhydrase, which is called as the fastest enzyme. We are going to study this in enzyme topic, which is having the metal called zinc. Flavoprotein. So flavoprotein, the best example is there in electron transport system. So they are present in ETS, electron transport system. So this is about conjugate type of amino acid, which is the most important topic for NEET examination as far as the basis of the protein classification on the basis of constitution is concerned. Derived protein is the third one, and why it is called derived? Because they are the outcome of the metabolism of protein. So when the protein is being broken down, it's being digested, it changes into metaprotein, proteose, and peptones. So these are the derived kinds of proteins. So this is about the classification of protein on the basis of constitutions. Next, we are going to understand the classification of protein on the basis of its structure. So we're going to make it into 4 different classifications. So when we talk about the structure, when we are going to talk about the structure, we are going to classify it into 4 different types. The first one is primary structure. Primary means what? They are present in a linear chain. When the amino acids are present in a linear chain. So these are the amino acids, the units of protein, and when the amino acids are present in linear chain, and the best example of that is insulin. And we know already about insulin, that it is being secreted from the beta cells of islets or Langerhans of pancreas, and it is used to treat, it is used to treat diabetes. So insulin is a hormone and it's a protein which is having linear chain of amino acids. So it comes under primary. The second one is secondary. So when we talk about secondary, that means the classifications. So we can classify it into 3 different categories. Number 1 is alpha helix. Alpha helix. Alpha helix means the same linear chain is present in a helical or spiral fashion, wherein the amino acid, the first amino acid is going to join with the 4th amino acid with hydrogen bond. And by this particular bond formation, they can remain in a helical fashion. And the example of the alpha helix is myosin, is keratin. So these are the examples of alpha helix. So when we talk about beta pleated, the second one is beta pleated. So beta pleated, under this we are going to study about that two or more polypeptide chains are present in a sheet, and they are present in a sheet and they are present in parallel or anti-parallel manner. So they are present in parallel or anti-parallel manner. Anti-parallel manner. And the example of this is fibrine protein of silk. Fibrine of silk. Fibrine protein of silk. Now what is silk basically? Silk is having two main compositions. There is the inner core and the outer part. Outer part is made up of a particular protein called sericin. And the inner core is tough, made up of fibrine protein, which is nothing but having the structure of beta-pleated. So fibrine protein of a silk is beta-pleated. Then third is collagen helix. So when we talk about collagen helix, that means collagen helix. What we know about collagen? Collagen is the most abundant protein in animal kingdom. We already know that. We have done it already. Collagen helix over here, the polypeptide chains or amino acids are present, but they are not one, they are three of them. So it's not a double helical, it's a trihelical strand. So trihelical strand of this particular helix is a collagen helix, and the best example of that is collagen. And this particular helix sometimes gets disrupted, gets desampled. How? By the deficiency of vitamin C. So if we have vitamin C, ultimately what is going to happen? Again the collagen is going to get formed. So there is a term called, see, this is what I am making for you, is the lips. And at the lips, at the corner of lips, sometimes you have seen in some of the people that there is some wound-like structure which is there in the corner. We call it as angular stomosis. We call it as angular stomosis, and this occurs due to the lack of vitamin C, because that particular structure is having less of collagen due to the vitamin C. Vitamin C is going to make all these three trihelical strands intact. So this is about secondary, we call it 2 degree, primary we call it 1 degree, and then there is a tertiary. Third one is a tertiary structure, we call it 3 degree. Now tertiary structure is nothing but it makes a three-dimensional tertiary structure, and by the help of some of the bonds like ionic bonds, covalent bonds, hydrophobic bonds, van der Waals forces. Then there is a hydrogen bond. So these are the bonds by which the polypeptide chains are present in a particular three-dimensional structure. And while studying the particular topic called enzymes in biomolecule topic, because every enzyme is having a three-dimensional tertiary structure. So it's a very complex structure because they have got this many number of bonds. And the example of this is myoglobin. It's a protein present inside muscles, myoglobin. The fourth one is even much more complex, because in quaternary it's a multimeric structure where it is having more than 2 polypeptide chains, and each of the polypeptide chains they have made their own tertiary structure. So what is the unit of quaternary structure? The unit of quaternary structure is each one of the polypeptide chain they make a tertiary structure, and so definitely it's going to be even much more complex. And the best example of this is hemoglobin. Hemoglobin, which is a pigment of RBC, which is a respiratory pigment. Fine? Or it's present inside RBC. Hemoglobin is highly complex. And we are also going to study the same hemoglobin in a topic called sickle cell anemia, where we are going to study about how the sickle cell anemia has been formed by the genetical problem, by the single mutation, point mutation. We are going to talk about that later in genetics topic. So this is quaternary structure. So on the basis of structure, we can classify protein into 4 different categories. Students, mind you, these 2 topics that I have covered in this video is very, very important for NEET examination. If you like this particular video, like, share and subscribe, and press the bell icon for further notifications. And if you got any query, you can ask me in the comment section. Thank you for now.